Hello, good afternoon. How's everybody?
Good afternoon, Professor.
Good afternoon,
Hey,
Professor.
good afternoon, Mohammed.
Good
Good afternoon, Jimena. Well, how's everybody else? I see like 7 people, and um, I see Sarah, your internet connection. I can tell, your internet connection is kind of unstable. Hope it will improve as we go on. So I see. Actually, I see only 6 people. One, just um. All righty. So I gotta. So everyone. Okay, let me first share my screen. Let me share not camera. The share application. All righty. There. Your connection is poor right now. Others will see your videos in lower quality. Okay, that's me. My connection is poor. I guess I have at least 7 people at this time. Let me also check the discussion board. Oh, there is the discussion board. No, that's FMA 100. So. Today is the 27th, and why is it 22nd? 28th. And how many people are here? Okay, 9 people. 9 people on 9 people have signed in to today's forum, but I have only 6 people here, and one person is coming in and out. One person is, I think that must be Safia, because I noticed. So you can see, everyone can see, right? Because I'm sharing my screen. Yeah, that represents your internet activity, right? Connection strength. And it looks like Sarah is having a unreliable connection today. Okay, so I haven't, well, it's until 11:59 p.m. today, but your homework one is due, and I believe you are aware of that. Right? Is this a surprise to anyone? The fact that your homework one is due today. Is there anyone to whom this is a surprise? I hope not. Has this been it's been announced multiple times? I mean, it was first and constantly, you were constantly reminded during the class. So we're done with the, let me pull up something. We're done with the, so we're moving on to the next topic, and you were supposed to have already studied a video, right? Because we're in topic 2 already. And even in topic 2, the first 4 videos are already more than 5 days old. That's why how many of you, tell me, how many of you are here? I mean, have you can't see these videos, but because they are grayed out, but what the videos that are in blue, they are the ones that are active. And single cash flow model, future value, part 1 through part 4, these videos were last available on July 27th. So that means they began to be available. They began to be available on July 22nd. So you should have actually watched these videos between July 22nd and 27th. And I wonder how many of you have watched it. Tell me, Christopher Silva, did you watch these videos while they were still available? Christopher, can you hear me? If you can hear me, raise your hand. If I don't hear the response instantaneously from you, instantaneously meaning within 5 seconds, then I will have to consider that you're absent. Okay? No matter whether there is your attendance report or not, I will have to, and no matter whether I see your name here or not, I will have to assume you are absent. Okay? So you need to reply, you need to respond within 5 seconds, because this is dragging on. It's exhausting me, and we are, being delayed by these, lethargic responses or lack of responses. And lethargy is the enemy of the class. Now, I'm not going to. The opportunities will be given to the people who are eager, and those who are not eager, there will be no opportunities. It's not, simply worth my time and other people's time, most of all. Now, Hannah, are you there, Hannah? Okay, Hannah, thank you you can lower your hand now. Hannah, did you watch these videos while they were still available? Okay, I have. Okay, good, thank you. So you did. Okay, that's the kind of response I would expect. John Henry, are you there? John Henry. Okay, no response within 5 seconds, so I'll have to consider John absent, regardless of any, record there. Maricel, are you? Yeah, thank you, Maricel. So did you watch these videos while they were still available, Maricel? Did you watch those videos? I don't know if this is old hand or if you raised hand again, Maricel. Okay, you can just raise your hand. So you watched. Okay, you watched those videos. Okay, thank you, Maricel. You can now lower your hand. I can lower it by force. Mohammed Sultan, yeah, thank you for responding. So did you watch those videos while they were still available? Thank you. You can lower your hand. Monique Amorim. Monique, are you there? Thank you. You can lower your hand. I'll lower. Okay. So did you watch these videos? All right. All right, thank you. This is new hand, right? Okay, thank you. You can lower your hand. And um, I hope your connection is better. Sarah, are you still there? Yeah, Sarah, thank you.
Yes,
Sarah,
Professor.
yeah, thank you. You can lower your hand now. So did you watch these videos while they were still available?
Yes, Professor.
All right, thank you. Thank you. I just want to make sure you are keeping up with the class progress. Jimena, are you there, Jimena? All right, thank you. You can lower your hand. Oh, I get. Same question. Did you watch these videos while they were still available?
Yes, Professor.
Thank you, Jimena. All right, at least other than like two people, John, Henry, and Christopher Silva, everyone is keeping up. That's a good sign. John, you didn't respond before.
Oh yeah,
John,
I watched the videos too.
yeah, but I asked that it was your turn. It was your turn a while ago, like 5, 6 people ago, and I asked you to raise your hand. You didn't, I,
Yeah,
and
my
so
mic,
you didn't. Yeah, I said you can
my
raise your
mic wasn't
hand.
working.
No, no, you didn't have to speak. You could raise your hand simply,
No, at all.
right?
Like I couldn't hear you. You were cutting off. You were cutting
Oh,
off.
okay. So you watch
I
these
think my
videos.
internet was down.
Yes, Professor, you're cutting
Yeah,
off a lot.
Oh,
yeah, you're cutting off.
hmm.
That's why I didn't really hear you at all.
Okay. My apologies. I don't know. From my end, I can't tell that if I'm getting cut off or if I'm breaking out. From my end, it's not detectable. But hopefully, but you see, my connection here. This is me. My connection is fine. I don't see any. For example, if your connection is poor,
Probably it's
I
mine.
can. And Christopher, so Christopher is not responding. All righty. So most everybody has watched those or keeping up. That's good. So now, without further ado, I guess I can. Let me first, pull up that file. I hope this is going to. All righty here. Where's the file location? Where's the file? Okay, this one is. And also, let me pull up my TV. Okay, time back. Maybe then time back. Hmm. Why not in the? Okay. Okay, now let's move on to compounding and or compound interest rate. So let me, before I do that, let me make sure I have it also in the business to 10, what chart? Simple interest. Hmm. Okay, yes, this is fine. Well, just bear with me. Just give me a few seconds. I'm just kind of, rearranging my file locations. So shouldn't take that long. All right. Oh, why? Why? Cannot be. All righty. So, okay, I got it. All right. So, remember, the last topic was based on, simple interest rate, right? Simple discount is also based on simple interest rate. And um, we didn't have, actually, um, today's already Wednesday, right? It's already Wednesday, and um, what? Actually, we should have got to this part already on Monday, but what can I do? So when we talked about the simple interest rate, I said already that I explained that Simple interest rate is used for short-term maturity, right? The short term means, less than 1 year, maturity under 1 year. And the financial market, where the short-term financial market is called the money market. I talked about that. And then, so in short-term financial market, most of the times it's like, discounting, simple discounting or bank discounting of the promissory notes, right? Short-term debt instruments, like, promissory notes, commercial paper, or, treasury bill. And I told you commercial paper and promissory note mean the same thing. They mean, short-term corporate debt. And it's mostly about, discounting those notes, whether it is interest-bearing or non-interest bearing. But, and I told you also in the long-term financial market, and if I told you there's a name for long-term financial market. Does anyone remember? I told you at the beginning that the name for short-term financial market is money market. But then what's the name for long-term financial market? Anyone remembers that? Does anyone remember? Come on. No one remembers? Christopher, do you remember what that is called? I would have to assume Christopher's not here. Hannah, do you remember what that is called? The long-term financial market? What's another name for that?
No.
No. Okay, then, John Henry, do you remember? Short-term financial market is called money market, but then what is the long-term financial market called? John? Okay, Maricel, do you remember? John, your microphone is on, so yeah. Okay, Maricel, so can you answer that? What is the long-term financial market called? What's the name for it? No? You don't know? Oh, yeah, Jimena. Yeah, you could raise your hand. Instead of, typing it into the, you don't have, Maricel had microphone problem, but Jimena, you didn't have microphone problem. So no Sultan, no Mohammed. Jimena already said it. It's called capital market. Okay? Stock market is a subcategory of capital market. Okay? So in long-term financial market is in general called capital market. Jimena, you can't say just is it capital, because that's not complete. It should be capital market, right? Because although the question was, long-term, what is long-term financial market called? So the answer should be capital market, not just capitals, because it could be misunderstood, right? It could be misunderstood as just saying capital. So in long-term capital market or long-term financial market or capital market, stock market and bond markets are the subcategories of capital market. And that means, also bond is long-term borrowing or long-term lending, right? From the investor's perspective, it is, long-term lending. From the company that sells the bond, it's the long-term debt instrument. So it's a long-term capital. It's capital. When we say capital means long-term. You don't call short-term borrowing like promissory notes for 60 days. You don't call that capital, right? That's not capital. It's liquidity. Okay, short-term assets. Liquidity is a short-term asset. Okay, liquidity is a short-term asset. From the company that received the promissory note, from the company's perspective, the company that received the 60-day promissory note, this is a short-term asset, but it's not capital. Okay, capital means long-term asset. And from the company that issued 60-day promissory notes, it's a short-term liability. Okay, everyone is clear about that. So for a capital market or long-term financial market, the way the interest rate accrues, the way you earn interest, the way interest accumulates follows compounding or compound interest rate. So without further ado, what is compounding? So I will have to let's go back to I really want to know how to use this whiteboard, because in the past I was able to write. See, I select the pen. Okay, I select the pen. And I could draw on it. Now I can't do it. It's not allowing me somehow. Even by, maybe if I turn it into let me try to put it into tablet mode. If it is in tablet mode, will I be able to do it? Now it's in tablet mode. And where is everything? It's in tablet mode, and I don't, I'm having it's gone. It's in tablet mode, and it's, okay, the item cannot be deleted. Let's see. It doesn't work even in tablet mode. Okay, maybe if I use a stylus. Now it's in tablet mode, I hope. Let's hope it's gonna work this time. No, it's not working, so there's no need for tablet mode. I'm gonna just close this. I'm going to have to close that. I'll just have to rely on the old method. Okay, let's think about it. So, can anybody translate this? I don't think it is that difficult, right? First of all, what does this mean? That's future value at the end of year one, right? So let's suppose we have $10,000 principal, right? Of course, dollar sign. Let me put dollar sign here. And let's also assume 10% interest rate. And let's assume time. It can be anything, time can be 1, 2, or 3. But let's say, we'll plug in, until ellipsis. That means, it will continue until we reach, any number n, right? So then let's try that. Let's try to plug it in here. So what's going to be the future value at the end of year 1 when principal is 10K, interest rate is, we know already, this is how you find a future value. This is basically from simple interest rate, right? Because if it was simple interest rate, if you're using simple interest rate, future value at the end of year 1 will be, right? You put this $10,000 at time 0, which is now the beginning of the year, and then the formula is, then P plus. Everyone should remember this. Future value is basically principal plus interest, and of course, interest is, what? Interest. Can anybody help me out here? What is interest? How do you find interest? I'm not gonna do this anymore because I'm just exhausting myself. There's no way, nobody's responding. And this is not something new or something difficult or challenging. This is something we already did in the previous topic, and nobody can tell me what is the definition of interest. Then I'm really disappointed, and it's really pointless to move ahead. Who can tell me what I is? Anyone?
I could do it, Professor, but okay.
Yeah, who is this?
Monique.
Monique, yeah, go ahead. Go on, Monique.
I is interest.
Yes, I is interest, but not the verbal definition. What is the mathematical definition of I? How do you find I?
You multiply rate, time, and principal.
No. That's true, but that's true, but yeah. I'm sorry. That's true. So you put it in a neat form, right?
Right.
Don't try to word it. Don't try to word it. Just give me the algebra. I don't need words, just the algebra. So what is I? Can you define
I is equals to P plus R
Plus?
plus T.
No, no, no. Why plus?
Yes, Professor. Sorry, not plus. Sorry.
Mhm.
Multiply. You multiply.
Yeah, yeah.
Multiply.
So do it again. Say that again.
Sorry, is P times R
Uh-huh.
times T. Sorry.
Okay, you're right. Okay, so uh, I don't have to. Okay, so please remember in this class, words are not needed. I mean, um, in other words, verbiage is not needed. Everything is neatly and concisely defined by by algebra. So see, the definition of I is exactly, in other words, we rewrote I by its own definition, right? So that was Monique, right? Isn't that right? That was Monique, right? So
Yes.
thank you. So Monique, and today is 0728. This is business 210. All right, Monique, you got 0.25 point for that. So again, then um, is this a good form? Hmm? Is this a good form? P plus P times R times T. Is this a good form? Huh? Can anybody tell me if this is a good form?
Is it going to be P times open bracket RT closing bracket?
Okay, who is this?
Mohammed?
Mohammed. Yes, thank you. Yes, this is not a good form because it's redundant, right? P is, uh, occurring, twice redundantly, right? And the math hates redundancy, basically. Um, hate is not a very good word, but then what? Math despises redundancy, or however you call it, uh, or math doesn't. Um, there is no respect, right? There is no respect. No respect is due. No respect is given to redundancy because it's like, uh, as I said before, this is a very poor sentence. If you say, John, I go to BMCC, and John goes to BMCC, and his sister Sally goes to BMCC. If you say like that, this is a very poor sentence. Do you understand why it is? And I repeat this over and over, um, because even in English class, this this will be given 0. Why? Because the sentence could be more concise and neat, right? You factor out the common factor. The common factor is go to BMCC, right? That's the common factor. Then it's like, in the parenthesis, you say John, comma, his sister Sally, and I. Okay? And I told you, putting I in the last part is a good form, right? If you say in spoken language, you may not always observe those rules. In spoken language, people just say, that's without thinking, because in spoken language, people don't really compose or neatly organize what they say. But at least in writing, you should organize it neatly without any redundancy. So, just like that, um, redundancy is pariah, right? Redundancy should be, because it's not, redundancy is unnecessary waste, right? So, this is not a good form. So we come to, yeah, the common factor is P. So it's P times, open parenthesis, 1 plus R times T. Right? And so you see what this is? This is exactly that. But where is T then? Where is T? Well, you see T is 1. In this case, T is 1. Right? Everyone understands? Why? Because it's FV1, future value at the end of year 1. Right? It's future value at the end of year 1. 1 year later, future value 1 year from now. So 1, you don't have to write. Okay? So now let's think about it. If we plug in, right, our numbers there, right? So it's 10K. We know it's 11K because it's 10K times 1.1. Oops. You don't have to use parentheses here because we already know we already have the the result in number 1.1, and therefore it is 11K. This is all right. So thank you, Mohammed. So you got 0.25. Okay. All righty. And then let's think about it. Let's think about future value 2 then. I got future value 1 here. So in our extending our example, it's going to be 10K times so that's 11K. All righty. And oh, no. Don't do that. Now, how about then how about future value 2, meaning future value at the end of year 2? Well, now let's think about it. Future value 2, right? Future value 2. At the beginning of year 2, what is there? What is sitting there in our account at the beginning of year 2? Can anybody tell me what is sitting there? What is sitting there in our account at the beginning of year 2? Anybody? 5 seconds. No one's responding, so I'm gonna have to someone said I can't see the slides. Okay, Sarah, you need to, I don't know why. Sarah, you're using the computer now, right? You're not on the phone, you're on the computer, right? And I think you may not be, may have a hard time hearing me because I can tell your connection is very poor. But if you can't see the slide, if you can't see the screen, it could be maybe most likely browser problem. It could be browser issue. So you might need to use another browser, whatever browser you're using. You might need to use another browser or upgrade your browser. Update your browser, you know. If you're using Firefox or Google Chrome, whatever, you can find, you know, there's an, you can update it. You can, in the setting, you know, you can find update button and you can update it. You might need to do that. Anyway, Chris, I will, okay, Sarah. So I will go from, you know, bottom here. Jimena, are you there? Jimena?
Yes, I'm here.
Okay, Jimena, can you answer my question? What's at the beginning of year 2, what is sitting there in our account? What is sitting there?
11K.
11K, yes, you're right. I mean, was it that hard? Because at the end of year 1, because why was such a thing like 5-second delay? Huh? There shouldn't, because at the end of year 1 we have 11K. So end of year 1 is basically the beginning of year 2. Isn't that right? Think about it. December, yeah, 11 midnight, December 31st of 2020 is the same thing as 0 hour, January 1st of January 1st of 2021. Isn't that obvious, right? Because at the end of year 1, 11K is sitting there. At the beginning of year 2, 11K is sitting there. And then this 11K earns, again, during year 2. Oh, this looks quite ugly. This 11K earns, again, 10% interest. In other words, interest alone is 10%, but together with the principal that was sitting there at the beginning of year 2, it's going to have to be, you know, 1.1. And then at the end of, so then at the end of year 2, what are you going to have there? Well, of course, the calculation is, you know, you don't have to do the calculation. I'm not asking you for the number. The logic, you can break this down, right? Because this is basically what 11K times 1.1 is exactly this. Isn't that right? Isn't that right? Right? Everyone? Yeah. And okay, Jimena. So Jimena, you got 0.25 point for that. So then, if you think about it, what is FV1? What is FV1? What's the definition of FV1? Can anyone tell me? And we did this already. What is the definition of FV1? Why nobody's speaking? I'll speak. I'll skip Sarah because I'm sure most likely Sarah's not well connected now. I mean, connection is okay. Monique, can you tell me the definition of FV1? Monique, can you hear me?
Yes, Professor.
Okay, can you give me the definition of FV1?
Is the future value in the second year?
No, FV1.
Oh, one is in the first year.
Yes, but I've been telling you, I don't want verbal definition. We have algebraic definition already. Can you give me the no words? Okay, I don't like I've been telling you, math doesn't like wordiness. You don't have to, in other words, FV1 is, yeah, future value at the end of year one. But that, you say that 1,000 times. It doesn't earn you any point. You have to define it like what? FV1 is?
P parenthesis 1 plus R.
That's correct. But you don't say P parenthesis. There, you're missing operating word. What's the operating word?
Multiply times.
Yes, times. So you should say it like that. P times, open parenthesis, 1 plus R, close parenthesis. Okay? That's the way everything must be defined, right? Not by words, not in words, no definition in words, but by concept, by its, mathematical logic, right? Everything must be defined by mathematical logic. Okay, since FV1 is this, since this is FV1, can we not rewrite this by its own definition? Right? So we can, if we rewrite, so I simply replaced it, replaced FV1 by its own definition. So then it becomes this, and then it is P times 1 plus R times 1 plus R. And we know very well this is not the neat form. This is not how you're supposed to do it, right? This is not how you're supposed to do it. It's 1 plus R times 1 plus R. So what's the better way of doing it? It's P times 1 plus R squared. Isn't that right? Everyone? So
Yeah, that's
Monique,
correct.
yeah? Right. So Monique, you got another 0.25. So that way, we are simply, we are defining it as, so in that case, all we need to do is, I mean, it's the same thing. You will get the same result. 10K times, oh, it's so hard to draw this. 1.1 squared. Okay, I barely drew it. And then extending this logic, think about it. Future value 3. Future value at the end of year 3. So what is the future value at the end of year? So let's think about it. At the beginning of year 2, at the beginning of year 3, what is sitting there? What's sitting there in our account? Huh? Can someone tell me what is sitting there in our account at the beginning of year 3?
10K.
Who can tell me? Huh?
10K.
10K? No. Look at who was that? 10K is Muhammad. 10K, yeah, you can break it down into that. But at the beginning of year 3, future value FV2 is sitting there. Isn't that right? At the end of year 2, there's FV2, and that is what's sitting there in our account, in your account at the beginning of year 3. And it's going to earn 10% interest for 1 year, just like this. Another 1.1. So actually, FV2, if you calculate it, it is 12.1K. Okay? Because 11K times 1.1 is 12.1. That's 10K times 1.1 squared. So 12.1K for another year is going to earn 10%. Okay? Whatever that may be. But we can also, we know, because what is the definition of FV2? What's the definition of FV2?
10K. Oh, no. FW1 times
Speak up,
1
please.
plus
Speak
R.
up. Speak up, please. Speak
Is
up.
equal the principal open bracket times open bracket 1 plus R.
Is that right? Is that all?
Wait,
What
no.
is the?
It's P times 1 plus R square.
Yes, that's the definition of. You are looking at it right there. The definition of FV2 is this, right? So I can rewrite that. I can rewrite FV2 by its own definition, right? So if I replace it like this, then I will have P times 1 plus R squared times 1 plus R. And we know 1 plus, we can do better. I mean, if it is 1 plus R squared times 1 plus R, then isn't it 1 plus R cubed, right? Isn't it 1 plus R cubed, right? So P times 1 plus R cubed, right? Now, so that means, plugging in the numbers, right? We can find FV3 by 10K times 1 plus 1 cubed, or to the third power, right? And if we extend this logic, we can define FVN, future value at the end of any number of years, n, right, by simply, right, raising 1 plus r to n, p times 1 plus r raised to n. And this process is called compounding, right? This process is called compounding. No, that means interest rate is compounded because unlike simple interest rate, in simple interest, this is the formula for simple interest, right? And in simple interest doesn't get compounded, right? In compounding, interest becomes part of the principal in the next year. Remember, in year 2, FV1 at the beginning of year 2, FV1 is sitting there just like principal. So in other words, principal plus interest is sitting there just like the principal at the beginning of year 2. And then FV2 is sitting there at the beginning of year 3, just like it, as if it were principal. So it's like principal is getting bigger each year by as much as the interest. So the interest gets compounded. Right? Does everyone understand that? Okay, Mohammed, before I forget, you're getting 0.25 points for that. So you can tell between compounding and simple interest, between compound interest and simple interest. Let's say I told you simple interest is not used in the long-term financial market, right? So there will be no comparison. But if we compare, I mean, suppose we put money in the bank for 10 years. Suppose we put, you put $10,000 in the bank for 10 years at 10% interest rate. Which would you prefer? Simple interest rate or compound interest rate? Which one would you prefer? Anyone? This is a very simple question. Easy question. Nobody's answering. Huh? Which one would you prefer? If you put your money in the bank, would you prefer simple interest rate or compound interest rate?
Compound.
Compound. And who said that?
Mohammed.
Mohammed, okay. Yeah, Mohammed, I'll give you 0.25 for it was a very easy question, but I mean, earning points is just there for you to take. It's for your taking, I mean, answer the question within 5 seconds. Answer the question, okay? It's like, I don't know, it's like a video game where, uh, it's an old video game because um, there are certain bonus or candies or candies or goods uh, and you move your cursor and make your player cross that point, you earn points, right? 300. Was that Candyman? Um, actually, I don't. The last time I played any video game was like 1983. Those were the days of arcade games. There was Gallagher and Pac-Man and something like that, Minesweeper or something like that. But then again, how you score, it's the same. You have to reach that. You have to reach that point, and so it's just like that. There are easy scores. It's something easy targets to score, right? There's cherry or pineapple. You just have to hit the target, right? Just move your cursor and hit the target, and then you score. It's just like that, it wasn't a challenging question. Yeah, you would prefer compounding, of course, because the future value is greater. I mean, you try this, for example, if t is 10, let's say 10, right? If t is 10, simply compare. FV10 is then, by compounding FV10 is P times, which is 10K, times 1.1 raised to 10 and if you do it by simple interest rate, it's going to be, I mean, from FV2, it is it is very clear. Compounding is the winner. It's 1 plus, 0.1 times 10, which is, which will be 1, of course. It is so hard to, okay. So if you just work out those numbers, but we can do this by using a calculator too. But the point is, we do it by Excel. We do it using Excel. But I would just like you to, I would just like to show you the calculator. Everyone has calculator on their computer, right? You can open it also on your cell phone, on your mobile phones. You have calculator, and you just don't know how to turn it into a scientific calculator. I cannot show you because But you know, depending on your phone, if you rotate it, if you rotate the phone horizontally, then it turns into a scientific calculator. Please check it out. Or some models. I mean, these days I have just Galaxy. You know, it's not the latest one, Note 8, but you know, if you just bring up the calculator, it's just normally standard, but there is a small icon that that has, you know, square root, symbol, pi, and Euler's number, Euler's exponential function e, and equal sign, and things like that. You press it and it turns into scientific calculator. But then, you know, let's do this. So I want everyone to open their calculator. Do you all have your calculator in front of you? Nobody's answering, so I will. Okay, good. Just one person answered. So let's do this. 10K. So basically, let's find future value 10 by compounding. So it's 10K, 10,000 times 1.1. Here's raised to, you see there that, you know, cone that's raising something to raised to 10. Okay, and there's no way to verify if this 10 is, it is, because the operator is this. Okay, there you go. Right? That's 25,937. Let's do this by, everyone got this result? Everyone got this result? Tell me, did you get this result? How come I hear nobody? You haven't got to this point yet? This shouldn't even take, you know, this shouldn't even take 10 seconds. Tell me, how many of you got this? Mohammed, did you get that result? Mohammed.
Yeah, I got the same thing.
Okay, John? Oh, that was John.
Yeah,
right?
I got the same thing. Yeah.
Huh? You got the same thing?
Yeah.
Okay, Mohammed, did you get the same number? Mohammed? I think you're lost. Hannah, did you get the same number? Thank you. All right. Christopher, are you there, Christopher? Okay, did you get the same result, Christopher? Christopher. Yeah, so so this new hand means you got the same result. Is that right? You can lower your hand and, you know, either confirm by raising another hand. Okay, thank you. You got the okay. So that's by calculator, but we don't need the calculator, because if you use calculator, you have to, for every problem, you have to do it all over again. So let's do this. Oh, where's my okay, so everyone, no. So do you guys all have this file opened in front of you? You have all, tell me, you have this file opened in front of you?
Yes.
Okay, one person only. Who was that? Was it Hannah?
Yeah.
Who was that? Okay. And what about the rest of the class? You have this file in front of you? How come nobody's responding?
Yes.
You can. Okay. John, yeah, that confirms that. Okay, Sarah. Yes, thank you. Monique, do you have it in front of you? Yeah, thank you. Jimena, do you have it in front of you? Jimena,
Yes,
thank
Professor.
you. All righty, so I believe Mohammed, you have it in front of you, right? Mohammed, John, do you have it in front of you? Please raise your hand.
Yeah. Yes.
Okay, good. Mohammed, you have it in front of you. Mohammed, I think Mohammed is lost. Well, I would have to assume everyone has the file in front. And if you have this file in front of you, please delete the highlighted cells. Please delete the highlighted cells. Okay. And so let's do this example. In this example, we have $1,000, right? Just to make it more interesting, it's okay, 1,000. Let's add one more zero there, so make it 10,000. And you're also automatically changed to cell A3 also changed to 10,000 because I made it equal to A2. So whatever happens to A2 also happens to is also reflected in A3. So then understanding this scenario is obvious. You have $10,000, you put it in the bank, right? The bank pays you 6% interest rate. You put it there for 10 years. Ignore column D, ignore M just for now. I'm going to get to that later. You put it there for 10 years. What's going to be the future value? Well, all you need to do is we follow this formula. We follow this formula, right? So can anybody guide me here? Can anybody? This is a good chance to earn 5 points. I mean, 0.5 points. Will anybody guide me here? What's going to be the future value of 10? Anyone? You're just being quiet. You're not, you don't want to earn any points. Let me try Hannah. Hannah, can you guide me here? Hannah.
Yeah, I can try, but I'm not
Okay.
really sure. But
Well, give it your best shot.
then equal.
So future value is equal to, right?
Then A2
A2, yes.
Times open parentheses
Open parenthesis.
1 plus
Plus
B2
B2, and then?
divided by.
No. You don't divide it by. Why do you divide it?
So no. Oh,
I
no,
said
okay, no. Yeah, just close parentheses.
close parenthesis, and then? What do you do next?
Then wait, I have to see here.
What's the formula? Huh? Formula is simply P times 1 plus R raised to N. So then what do you need to do?
Take the, I don't know the symbol, but
Just say raised to, that's it. Raised to power, raised to. And
raised
raised to, okay, that is, that's called, caret. That's the symbol has a name, caret. It's pronounced like, carrot, the legume, right? Red carrot or diamond carrot, but it's actually, it comes from French word carré, meaning square, right? This is also in French they call it accent circonflexe. It's a French accent. In French orthograph. it's a writing symbol, but it means it's a universal machine language. It's a universal machine language denoting or machine language for raising something to power, right? Raising something to power. So raise to, and then what?
Raise to, yeah, the n, but I can't see. Should it?
And here.
Oh, is it the D2? No?
No? Why D2? I said
Oh, it was at M. Okay, no.
we ignore for now column D. Okay? Ignore column D for now. So what is N?
Is it F6?
What F6? Why F6? We are working on row 2.
Yeah, but
There's
I can't
no
see
such
the N.
Why can't you see the N? What is N here? Huh? How many years are we keeping the money in the bank? How many years are we keeping the money in the bank?
10.
8 years?
10?
10 years. So where is that 10?
C2.
C2, yes. Okay, there you go. This is what it is. I said we are, I told you, you ignore this. There's no column D, ignore that. What was the scenario? Remember, this is the formula for compounding, right? Future value at the end of n period or year n, that's principal times 1 plus r raised to n. So this is putting your $10,000 in the bank for 10 years. So then what should be the future value? There's no, you don't have to say number, you don't have to say word. It should be defined only mathematically. It should be defined only algebraically. It's p times, right? 1 plus p times 1 plus r raised to n. Right? That's a2 times 1 plus b raised to, right? C2. So, Hannah, I'm going to give you 0.25 because you didn't complete. And who helped out at the end? Who
Me,
helped out?
That was
Who is that? Who gave
Mohammed.
me C2?
Mohammed.
Yeah. Mohammed, okay. All righty. So, Mohammed, you got 0.25 for that. Okay. So, and also, didn't I tell you, I mean, when I use the, calculator, right? And history, there's no history. Oh, what? There is a history. I did. Oh, okay, memory. Nothing in the memory. I deleted everything. When we worked it out on the calculator, right? What was the formula? Huh? I mean, it was 1 point. We already knew it was 1.1, right? So, okay. And raised to 10. How did I raise it to? And when I did this, when I clicked on this, don't you see what's happening here? Don't you see? It may not be very visible because on you're watching it through the blackboard, and in the blackboard this may be too small for you to see. But if you also did it on your computer, if you also use the calculator on the computer, You must have seen this when you raised it to power, right? You must have seen this symbol. You could have known that that's the symbol for raising something to power. When you do that, when you press this, that's what happens, right? That's what happens. So also, let's see if we change our APR to 10, if we change our APR to 10, what's it going to be? It's exactly, that conforms, right? That confirms our result, the same result, right? Same result. Okay, so it's 4:28. Let's take a 5-minute break and reconvene exactly at 4:30. Give me 2 more minutes. So 4:35. Reconvene at 4:35. Okay, reconvene at 4:35. All right, we're back. We're back. Okay. Now, let's think about what this M is. Okay. Let's think about what this M is. Now we have assumed that the interest is earned, or interest is compounding annually, once a year, annually, right? So far, we have assumed that the interest is compounding once a year. Okay, but there is no guarantee. I mean, it was just for simplicity, right? But in reality, interest can be earned. Interest can be earned multiple times a year. For example, when you borrow money, right? Or let's say on your credit card, right? When you charge something on credit card, right? When you use credit card, you make the payment monthly, every month, right? And the interest is assessed every month, right? On the monthly balance, right? Also, if you think about it, has anybody ever had a CD account? Hmm? Did anyone ever have a CD account? Nobody's in over. Okay, do you understand what CD is? Anyone understands what CD is? Hmm? Christopher, do you? Okay,
This-
Monique?
The
Yeah,
certified,
Monique.
I think it's called certified deposit account.
Yeah. Certificate of deposit, right? That's right. Yeah, Monique. So you got 0.25. So yeah, certificate of deposit. So what is that? What does that mean? Certificate of deposit is savings account, basically. It's savings account. But what's different from regular savings account is that your money is tied up, right? If you have a savings account, there is no there is some restriction, because they will you cannot they will tell you that they will tell you not to withdraw money from your savings account more than twice a month. No more than 2 withdrawals per month is allowed. Generally, they don't want you to withdraw money that um, but even if but there is no penalty for withdrawing money. I mean, there is no restriction. There is some restriction, like 2 withdrawals per month. But if you make more withdrawals, more frequent withdrawals, then they will tell you to move your money to checking account, right? And why is that? Why do you think they do that? Huh? Why do you think they say that? Hmm? Anybody? You don't have any idea. Well, there is a difference between checking and savings, obviously, because they are they are different categories, because they are um, treated differently. First of all, checking account, money in the checking account is called demand deposit. And what does that mean? Demand deposit means something that they have to give up, something that they have to give out upon demand. In other words, you can make withdrawal anytime, right? You demand your own deposit, so they are um, they have to give it out to you. So there's no restriction. No matter how many times you withdraw your money from checking account, no restriction. But the money in the savings account, they want to use it to lend for long term. So they need you to commit to that deposit, right? So that they can commit to a long-term lending. Suppose you have, $1 million in savings account, right? And then what does the bank want to do with that money? They will have to lend it out. Isn't that right? They will have to use that money to make profit for themselves and to pay out interest to you, right? You understand? So money in the savings account, the balance of the balance on the deposit held in the savings account must be maintained at constant level. Otherwise, they cannot commit to a long-term lending. But then again, there's no way they can enforce two withdrawals per month. They cannot enforce that rule because still it's your money. You can withdraw 3 times or 4 times, 5 times, depending on your need, and it's your money. So if that is the case, then the best thing they can do, the only thing they can do, is to ask you to move the money into checking account. Okay, but then basically the business of banking is in lending, because they make money by lending money. Isn't that right? Banks make money by lending money, right? Banks don't make money by taking deposits, because if they take deposits, they must pay interest. So it's an expense for them, not income, right? But anyway, by taking the deposit, then they can lend, so that they can make, they can charge interest and make income for them, generate income for themselves. So to lend, they want to lend long term, right? And because long-term interest rates are higher, long-term interest rates are greater than short-term interest rates, always, right? Because to lend long-term, right, there's got to be more incentive than lending short-term. So they want to lend long-term, so they need the funds to be committed. In other words, the money to be tied up, so that they can make a long-term, use it for the long-term lending. So that's what the certificate of deposit is about. Because if you open a CD account, then that means you're committing to that deposit for 2 years, or for 1 year, or for 2 years, or for that contract period, right? And if the contract period is 2 years, that means you aren't going to withdraw that money for the next 2 years, right? And if you withdraw, you can do that, but then you are breaching the contract. You're in the breach of the contract. You will have to terminate the contract. And for any early termination of the contract, there is always what? If you early terminate any contract, if you breach the contract or early terminate any contract, what's going to happen? This is just a common sense thing.
You pay penalties.
Yeah, of course, there will be penalties. And who was that? Was that Monique?
Monique, yes.
Yeah. Okay, Monique, you got another 0.25 point. Yes. There will be a penalty if you early terminate a contract or breach a contract, right? Yeah. So then, you can do that, but the CDs generally, because then you won't earn. I mean, CDs pay higher interest. CDs pay higher interest than regular savings, because your money is tied up, right, for 2 years or for 1 year or for contract period. So they have to give you higher interest rate. That's an incentive for putting your money into a CD account. So you're not gonna get full interest if you early terminate, because it's a penalty, right? There's a penalty. But if you ever had a CD, you may have noticed how often do they pay interest? Of course, it depends on the contract, but you may have noticed that although you will only see the interest, at the end when you withdraw the money, at the end of the contract period, right, at maturity, but some CDs you will see some CDs earn interest semi-annually, or annually, or semi-annually, or quarterly. You understand? You may not, when you have a CD contract, all you have is just that CD contract, and unless you check that account frequently, but these days you can check your CD account online, so you would notice, you may have noticed, the CD has the balance when you check through your a mobile banking app. You may have noticed that the interest was paid semi-annually or quarterly. Okay, what does that mean? Of course, that is nothing challenging or difficult to understand. CD interest can be paid once a year, which is annual, or twice a year, semi-annual, or quarterly, right? Every 3 months, right? So then 4 times a year, quarterly, or it could be monthly. I mean, monthly is hardly used, but in CD, but it could be monthly. It could be even weekly. It could be daily. So let's think about this column column D, which is labeled M. And what does that M mean? So here we need to define a couple of things. And I believe I did it somewhere here. Maybe not. So we all understand P is principal, right? Everyone understands P is principal. There's nothing, nothing new about it. P is principal, right? APR is annual interest rate, right? Annual percentage rate. T is time in years. FV, future value. What is M? Okay. M is the compounding frequency per year. Let me do this. So everyone can see this. Is everyone looking at this PowerPoint? Tell me, everyone is looking at PowerPoint?
Yeah.
Okay, thank you. And so what is M? M is compounding frequency per year. It can be 1, 2, 4, 12, 55, 52, or 365. But we don't generally use 52 or 365. Theoretically, it is possible. And most of the times, 1, 2, 4 is common. So think about it. If interest rate is 10, you understand it's quarterly. 12, if compounding frequency is 12, then that's monthly compounding. Compounding happens. Interest is paid, monthly, 12 times a year. 52, weekly. There are 52 weeks. 365 daily. Okay, and then That means every time interest is paid, every time the interest is paid, what is the actual interest per each period? It's simple. It's APR divided by M. APR divided by M. Okay? So think about it. If interest rate is 6% a year, just to make it simple, 12% a year. If interest rate is 12% a year, and if compounding is twice a year, semi-annually, what should be the actual interest rate applied every 6 months? So what is the interest rate? What is the interest rate that you earn every 6 months? Anybody? Is this so difficult? I don't understand, you know? This is not challenging at all. Even a 6th grader can answer this. Look, if APR, I've been telling you, interest rate is always, all the rates are expressed as annual all the time. Right? Do you remember that? So then if interest rate is 12%, and if the compounding is semi-annual, what is the actual interest rate that applies semi-annually or every 6 months? What should it be? You all get, I should give you all penalty of negative 0.25 for not answering this. Nobody understands the question, or nobody understands the question? Christopher, did you understand the question? Is there any problem understanding the question? Christopher, you don't answer? Huh?
Would it be 6%?
Yeah, 6%. Yes, of course. Why couldn't you answer? Huh? Yeah, of course, every 6 months it would have to be. So you got 0.25 point. If you didn't answer, you could have got that off, right? You could have, you would have, lost that point. I mean, for penalty, and you might wonder, I didn't even earn anything. What do I lose? It will be negative. Okay, it will be negative. Okay, so good. And if compounding happens quarterly, 4 times a year, of course, if annual rate is 12%, what should be the rate per each quarter? What rate do you earn each quarter? Hannah, can you answer that? Is this so difficult to understand? Hannah, are you there?
Yeah.
Yeah. So can you answer the question? Annual rate, APR is 12%, but interest rate is compounded. In other words, it's paid every 3 months, quarterly, right? So what is the actual interest that applies every quarter?
Is it 3?
Yeah, of course, it's 3%, because, if it is 12% a year and compounding is 4 times a year, it must be 3%. Okay, Hannah, you got another 0.25 point for that. Okay, Jimena, are you there, Jimena?
Yes, I'm here.
Okay, Jimena. So interest rate is 12% annual, and then the compounding is monthly. That means you earn interest monthly, right, every month. Then what should be the rate, actual interest rate that applies every month?
1%?
1%. Yes, you're right. So, okay, you got another, 0.25 point for that. Hannah got also another 0.25 for that. So this is easy. Why didn't anybody answer? And I lost almost, I have only 4 people left. And what happened to the other people? I think they just took off, or, connection. They lost the connection, but that's the point, That's what this M stands for. That's the compounding frequency per year. So now let's tweak this. Let's tweak this formula now a little, because now we call, okay, so if we make that adjustment, so APR divided by M, so that is the annual rate adjusted for compounding frequency, and that's called the periodic rate. So meaning that's the rate that applies at each compounding period. Okay, that makes sense. And now we use R. R is the generic symbol for, it's the generic symbol for rate. So it's the actual rate that applies. APR is always annual rate. So now R means periodic rate. And T is time, but T has meant, T has been used, for us, T was in years, right? T was given in years. But then if the compounding is quarterly, over 10 years, how many compoundings actually happen? How many compoundings actually happen over 10 years? Christopher, can you answer that question, Christopher? If compounding frequency is quarterly,
40?
but over 20, yes, yes. Christopher, so you got another 0.5. All right. And Hannah, if compounding is monthly, right? Compounding frequency is monthly, over a 10-year period, how many actual compoundings happen, Hannah? Hannah, are you there?
I'm here, but I didn't really got that.
No, this is a very, very easy question. Compounding is monthly, right? That means how many compoundings a year?
12?
12, yeah, that's the compounding frequency per year. And the holding period, I mean, you put the money for 10 years and compounding is monthly. So how many actual compoundings do happen over 10-year period then?
Is it 120 then? No?
100, what? Say that again.
No, but I said 120, but it's wrong.
No, you're not wrong. You're correct. 120
Yeah.
compoundings. Think about it. Compounding happens monthly, and you put the money in the bank for 10 years. So then 12 times 10, 120 times compound.
Okay.
So that's the actual number of compounding, and that's n. N now denotes, right? N denotes
Yeah.
actual number of compounding. Okay, alrighty. Hannah, you got additional 0.5. So we can tweak our formula a little now. So now it makes sense. Do you understand this? So now the formula was simple like this before, and then future value is equal to principal times 1 plus R, and this R was previously annual rate raised to n. This n was a number of years previously, but now this R means this R means periodic rate, not necessarily annual rate. This n means actual number of compounding, not number of years, because the formula was tweaked this way. So because we have compounding frequency, we have to make adjustment for that. If compounding frequency is 4, we must divide APR by 4, right? So that it would be quarterly rate, right, which is the periodic rate in this case, and then it will be raised to m times t, because m is, if it is quarterly, then over 10 years, there will be 40 compoundings. If it is monthly, over 10 years, there will be 120 compoundings, and so on, right? So making adjustment like that, I can do it like this. Now, reflecting this m, compounding frequency is now quarterly, then we divide by 4 that, and then we multiply 10 by 4, because over 10 years there will be 40 compoundings, right? 10 times 4. And enter. There you go. There you go. Now this says, and let's drag this down. And if you drag it down, what do you have here? The formula has been tweaked. The formula has been tweaked, but you know, it doesn't change anything, because m is 1. If m is 1, that's annual compounding. So with or without this adjustment, right? Still the same result. Still the same result. It's still the same result. But at least this way we can keep the formula consistent and uniform, right? Previously we didn't tweak the formula, right? But you know, if compounding frequency is 1, it doesn't make any difference. But then by tweaking the formula, at least our formulas are uniform, consistently uniform, right? Consistently uniform. And that's what's important, because if we have, let's say I have only 2 problems here, but if we have like 100 problems, if we have 100 problems of the same pattern, I don't have to do it, you know, I don't have to do it all over again, one by one. I can just simply copy and paste it. So under any, even in different contexts, I mean, as long as you have the same structure, problem has the same structure, right? Principal, APR, time, compounding frequency, I can just copy and drag it down and replicate it over and over, right? Makes sense? And here, what is this? What I did here is, instead of, look, in this cell, I use this formula, right? In this cell, in these cells, I put this formula there, right? But if I bring up, what I did here is, what is this? This is exactly APR over N. And this is T times N. Right? So what I did here is basically, it was, you know, I brought this adjustment out of the formula, right? So simply by adding 2 columns, here, where I put the intermediate calculation, APR over M, and you know, T times N. So on the separate, separate columns or separate labels, then I simplify the formula. In other words, I don't have to make that adjustment in the formula. The adjustment to the data has already been made outside the formula. Then in the formula, all I need to do is simply P times 1 plus R. That's r there raised to n. There's n there. And voila, right? Voila. It's the same thing. We came to the same. So it's just a matter of, preference, and I prefer this because when the formula is more complex, this is not a very complex formula, but it is easier to fix the source of the problem. When something goes wrong, you have to look into the formula. You must identify you must analyze the problem. You must identify the source of the problem. But if the formula is complex, it becomes more difficult to identify the source of the problem. But if the formula is simple, right, then it's easier to identify the source of the problem. If the source of the problem is this, it can be easily identified. If the source of the problem is this, it can also be easily identified. So I prefer simpler formula. Okay. Anyway, that's it for today. That's it for today.